All right, Pavan is here, so that's why we're starting. Okay, I love this. I ask you all to introduce yourself to each other. Now you're gonna keep talking. That's nice. All right, folks. So first of all, thank you all for coming. Thank you all for being here. So this is San Francisco Bay Area Ruby Meetup number 6. And these are happening basically every month now. And this is all thanks to all of you. Look around. This is an amazing group of people that I'm so excited to be with every month. And I know you folks are also enjoying it. That's why we keep it going. There's something, like I said, something new happening today. And this is the live stream. So we're actually live streaming right now, thanks to our amazing host, GitHub, and their AV team. So we actually started the live stream a little bit earlier just to check that it works. So there's a chat, but just because we're doing this for the first time, we couldn't really promote it beforehand because, frankly, we didn't know if it's going to work out. Now we have this link. So I want to ask you to maybe share on your socials and maybe on your Slack or somewhere with your colleagues so that they can join and share this live stream with us. Yeah, thank you. So first of all, I know I said it before at one of the meetups, but this keeps being super inspiring. Ruby meetups are back. And just look at this. These 3 rows. This is not all the meetups that we have on this amazing website, rubyconferences.org. So if you need any travel inspiration, you'll find Ruby meetups and conferences happening right now in every part of the world. There's like 189 of them planned. Isn't it crazy? So yeah, and here in San Francisco, we started in March, and we're back to where we began actually, because the first meetup was here. Anybody who was here back then? Hey, nice. You see, but what's interesting is that it's not like the same people. We have new people. We have a rotation of faces. We have like about 550 subscribers on Luma. And so we had New Relic, Product Board, Cisco Meraki, Y Combinator, and now again GitHub hosting the meetup. And I'm gonna just say again, all these companies are hiring Rubyists. So just go check them out. They are really nice places to work and to host the meetup, of course. Now, who's gonna be next? What do you think? Before I say that, a message from our sponsor. And our sponsor today is the company that I run, Evil Martians. And I'm gonna tell you a little bit about us. So we are a distributed team with offices in New York, Portugal, and Japan. and California now, but it's just me. So what we do, we consult startups. We focus on products for engineers, products for developers. We focus on startups on Rails, of course. We do a lot of real-time and collaboration-heavy products. And the new thing is local first applications. And we do a bunch of different services for them, from design to building complex systems and improving performance and scalability of startups. So that's just if you're curious what we do beyond open source. But of course, we build a lot of open source. And the way I think about our work in Rails community, in Ruby community, is building the missing tooling for startups. So we have big companies, GitHub, our gracious host today, Shopify, other big companies building amazing tooling for Rails. And we are bringing something that's missing specifically for fast-growing startups. So this is our role, and you might recognize some of the open source we've built. So the one on the right are Yabida and TestProf. The others have the names. And this is the page where we collect all the recommended kind of missing bits of Rails for startups. So this is something we want all startups to check out. And just a second about me, I'm Arina, the CEO at Martians, and you should go and check this keynote at RailsConf that I've given this year. And I know people, I talked about new startups built on Rails, choosing Rails in 2024. And it was a super emotional moment. There's a recording on YouTube. And if somebody is asking you, are there any startups choosing Rails today for new products, for new businesses? This is the best answer. Thank you. And yeah, and of course, reach out, let's talk about startups, and you have my contact details right here. So where we were, we're talking about the next meetup. The next meetup is gonna be on October 10th at Chime. I gotta say, I didn't know that Chime is running on Rails. And I started kind of thinking about them for a second when, you know, they're now on the list of startups that are about to go IPO next year, something like that. Kind of, there's some news around them. And then I just realized, oh my God, this is a Ruby on Rails company. And they have a I Love Ruby team inside. Anyway, that's for the next time. So you should sign up on our Luma page, but I will try to invite all of you as usual. And we'll see each other in October. Finally, propose a talk. This is important. You guys know, we're not just some random meetup. We have a CFP. So you have a link on every meetup page. You can submit your talk proposal, and I want you to do this because the goal of the meetup is to connect people with different backgrounds and with different angles at Rails. Somebody is just new, somebody's been building with Rails for 15 years, somebody's struggling with something, or somebody's mixing Rails with Next.js, etc. Right? There are many different angles at Rails. Let's bring them all here and share. So I hope I didn't bore you too much. So with that, we're going to be beginning our amazing program today that I'm really excited about. So I'm going to just say before the break, we have Cameron from GitHub talking about web components. It's a catch because he's a maintainer of one of the maintainer Vue component, but we're talking about web components today. Takashi from Shopify is going to talk about YJIT, which is kind of crazy. I don't know if everybody else is as excited about it as I am. And then after the break, we're going to have people from, I'm going to say from startups, so we have Shopify, GitHub, beginning. And then after the break, we have Brad from Fly, Kamil from Plane, and Konstantin from Academia.edu. And we're going to talk about a bunch of other new things happening in Rails. And we also have an open mic right after the break. So prepare your announcements, questions, things you kind of struggle with, and come on stage, share. You will find people to connect to. That's the purpose of this event. So yeah, without further delay, let me introduce Cameron. Thank you, guys. We're going to have about 5 minutes for questions after each talk, and we have a mic for the questions that I'll be able to give you. Okay? That's a cool font.
Thank you, Keynote from Apple. I'm going to try to figure out screen mirroring really fast. So I want to see the next slide. Let's see. Displays. Here we go. I want to go decimator. Nice. How do I do this? I want to say advanced. Does anybody know how to like arrange? Thank you. Where's arrange? Oh, there we go. Thank you. God, I feel like this has changed. I'm trying to not mirror. Yeah. Click what? Down? Oh, done. Okay, yeah. Yeah. Use as. Oh, yeah. Oh, there we go. Wow, that's okay. Anybody work at Apple? Because that's hella confusing. Okay. Hey, there we go. Okay, we're in business. Okay. Hey, everybody. Thanks for coming. I'm a huge fan of these Ruby meetups, and I just want to shout out Irina for doing a phenomenal job organizing them pretty much single-handedly. So round of applause for Irina. And round of applause for Evil Martians for supplying the pizza today. That actually was not supplied by GitHub. That was Evil Martians. So at the last meetup, which was at Y Combinator, one of the Y Combinator employees, I just was randomly talking to him, and he goes, "So are you speaking at the next event?" And I was like, "No, I've already spoken at too many of these things. Let's let other people talk." And now here I am talking again in front of you. So sorry about that. However, part of that is because Irina didn't get that many talk submissions, at least not sort of within the first couple of weeks. And so I'm here to stand in front of you and say, please submit your talk ideas, because we'd love to hear from you, no matter what you're dealing with. I'm going to give a talk about web components, but I'm sure you all have lots of knowledge in areas that I don't have. And so it'd be really cool if you'd speak in front of us. That'd be awesome. And it's a low stakes sort of, I would say, opportunity compared to like RailsConf or RubyConf, where there's like potentially 700 people in the audience, right? Like we've got many fewer people, more intimate settings. So if you want to sort of cut your teeth on talking in front of a group, this is a good place to do it. All right, so let's get going. Okay, so who am I? I'm Cameron. I work for GitHub. You can follow me on social media. And I know this is a Ruby meetup, and so that's why I feel obligated to show you this slide, which is that this talk is actually going to contain probably an abusive amount of JavaScript, and I have to apologize for that up front. But I also want to sort of talk about the dovetailing of Vue components with web components, because as Irina mentioned, I have sort of in the past maintained Vue component. We don't have a lot of activity on it these days, but it's one thing that our team at GitHub owns and maintains. So the intersection between these is interesting to me, and also I think you'll find that should be interesting to you too. So let's just really quick talk about what web components are. So web components are kind of the web's like official component implementation. So we might think about React or Vue or Svelte as having component implementations, but those really are not web native, and web components are. If you've ever sort of used a custom element before, like really any element that isn't part of the HTML spec, then that's a custom element, and web components are like custom elements with attached behavior. They also can provide like sort of rudimentary basic HTML templating, although we're not going to cover that today. That is a possibility. And they also offer this really cool thing called the Shadow DOM, which is now sort of part of the web standard or the web platform. Sort of previously, all you really had for Shadow DOM was React, and that's sort of now come to the web, which is pretty cool too. So what are some features of web components? Well, like I said before, they are they're web native, platform supported. So you can use them in any browser. They have this Shadow DOM concept. They also can, because of the Shadow DOM, they can encapsulate your CSS styles. So you can attach styles to a web component. And if it's attached to the shadow root, then those styles will not leak out to the rest of your application, which is pretty cool too. They also feature a bunch of lifecycle callbacks. We'll talk about those in a second. So how does GitHub use web components? Generally speaking, the way that we do this is we render HTML via a Vue component. Could also just be a regular Rails partial or Rails template. And the HTML includes custom elements, which again are just regular HTML elements. And then we add behavior to those elements using the Web Components API to add any sort of dynamic behavior that might want. Now, GitHub also uses React, so I'm not saying that this is a replacement for that, but there are a lot of places on github.com, and I would say also in a lot of websites, where a whole bunch of interactivity or a whole bunch of dynamicism, is that a word? Dynamicness is not really necessary. Maybe a little sprinkling. We've heard DHH, I'm sure, talk about sprinkles of JavaScript. It's kind of where Stimulus came from. That's, I think, true for a lot of different components and websites on the internet. Okay, so let's look at an example of how this might look in practice. So this is a much, much simplified version of a component from our primer design system. We have a whole set of components in the Vue components framework that are under the primer namespace, and one of them is text field. And you can see that this is just a regular Ruby class. It's nested within some modules, and it inherits from primer component. So this is a Vue component. If you want to hear more about or read more about Vue components, you can go to vuecomponent.org. So it takes in a couple of parameters, sets them as instance variables. So pretty normal. And then there's an accompanying template here. And the template, when you render this Vue component, this template is what gets rendered. And you can see it's just interpolating a couple of those values that we set to instance variables in the template. So you would then render it like this. You make a new instance of text field, pass in some parameters to it, and that would result in the following HTML. So that's very, very quickly how Vue components work. There's a class, there's an associated template, and you render that class, an instance of that class, and it generates HTML. Now you can see that what we've done here is stuck this primer text field, which is not a standard HTML element. We've stuck that around our label and input here. So from now on, the rest of the talk, I'm going to kind of just hand wave over the Vue component part. We're just sort of assuming that that works. I'm just going to show you the generated HTML and then the JavaScript for the web component. Speaking of that, here's sort of the basic web component structure. So all that I really have to do is define a class and then attach, or I should say call define on window.customelements, giving it my custom element that I now want to associate with this JavaScript class. So that means at any time this primer text field element is seen on the page, the browser will automatically make a new instance of this class and attach it to that element. So pretty cool. And you can see there's also an example of a lifecycle method here called connected callback. And this is just fired whenever the element is attached to the DOM. It's an example of the lifecycle callbacks that are available to you as part of the web component spec. Okay, I talked a little bit about primer. There's two implementations of primer. We have primer Vue components, which is for Rails, and we have primer React, which is obviously for React. And I think what our goal today is going to be is by way of sort of showcasing web components, is we're going to build this text field element from primary view components. We're going to add a couple of features to it. So we're going to add a clear button, and we're going to add what we're calling auto check functionality with a leading spinner, some error and success messages. It'll become pretty clear, I think, as I show this, how that's going to look. So here's an example for the clear button. All that we do is there's just a clear button. You type some text, hit the X, and it clears that text out. All right, so let's dive into how we might do this in web components. So the first thing we do is render our component, show clear button true. We added a parameter to our web component. Oh, I also forgot, there was an error on this slide. I forgot to pass in the name parameter here. Should be label name and show clear button. And that results in this HTML. So it added a button here. And by the way, don't get hung up. This is very simplified markup. This is not the way the markup would actually look. Because there's lots of CSS and whatnot in there. So I stripped all that out. We're just looking at the bare bones HTML here. We've got the input, of course, and we've got our button, and I've attached a class to that button called clear-button. And we have an oct icon here, which is our set of icons at GitHub, which is the X. And when that X is clicked, the idea is that it will clear the contents of the input. Okay, so let's look at our skeleton again of our web component. In connected callback, I'm going to add an event listener. And one sort of interesting thing about web components is that if I add an event listener on this, and I define a special method called handle event, then any event that bubbles up to the web component will get handled by that function. So it's kind of a nice way to sort of defer adding event listeners. I'm also going to define a couple of private functions in here that look for our clear button and look for our input. And here's the handle event I was talking about. So this is wired up by virtue of the fact that I'm adding an event listener to this. So when that button gets clicked, that button bubbles up to the primer text field element. Then handle event handles that event, and we're checking to see if the event's target is the clear button, if the type is click, and then we call this function called clear contents. And that's really simple. We just grab our input element and set its value to empty string. Okay, so that's very generally, or not even very general, that's really all you have to do to sort of get this behavior enabled. And we didn't have to go render anything from the server. We didn't have to go any React. We just literally wrote a couple lines of JavaScript, and now we have this functionality. Okay, so can we make it even simpler than this? We can. And that's why GitHub wrote a library called Catalyst. So I'm going to show this because a lot of our components at GitHub use Catalyst, and it can sort of cut down on the boilerplate that you might otherwise have to write for a web component. So it's the tagline on the website, catalyst.rocks, is web components made easy. There's two main concepts with Catalyst: targets and actions. So as you may have remembered from the last example, we had to query selector for our button. We had to query selector for our input. Catalyst makes this easy by assigning targets or by querying for items using targets. And then you can also wire up events to your buttons and whatnot using actions. So let's add some targets to our code here. So first of all, we import controller from GitHub Catalyst. We can then add this decorator to our element class. And when we do that, we can get rid of this custom elements define that happens automatically for us from Catalyst. I'm also going to import the target function here, or target decorator. And now I can add this @target decorator onto input element, which is a field on our class. It's an HTML input element. And that's enough to sort of get us going, right? Like now inside this class, we can say this dot input element, and that will automatically fetch our input. Now, there's one other thing we have to do, and that is add a data target attribute to our input. If you ever use Stimulus, I think Stimulus is similar to this. We've got primer text field dot input element that directly maps to like the name of the custom element, and then input element is the field we want to set that on. So by doing this, these two things, we now have the ability to say this dot input element in our class and get a reference to that element. We can also add our clear button. And again, that's just a matter of attaching a data target to our clear button. And now in our code, we can get rid of, now we can do this, jumping ahead. We still have our add event listener for click, but this time we didn't have to write any of those little functions that grab each element. We just can rely on Catalyst doing this for us. And I've omitted part of the code here to sort of show how this looks now. I had to do that for space reasons. You can imagine there's still the targets in here and everything, still an @ controller at the top. And now all we have to do is we just say this.clear button, this.input element. Those things are automatically wired up for us. We don't have to do any sort of messing around and running query selectors or anything like that. The next thing I want to show you is actions. So I mentioned that not only can you search for elements on the page or within the custom element, you can also wire up events using actions. So let's look at our code again. We should be able to remove all this code. So now all we have is clear contents. And then to wire this up to our button, we can just add a data action here. The action, the event is click. So whenever the button gets clicked, it'll fire a click event that gets sent to this function called clear contents gets called. So event name, we have the custom element name, and then the function that should be called. So now this is our final code. This is all we actually needed to do using Catalyst to get this to work. So we've got our target up front there. We don't even have to have a target to the button anymore because we don't need to actually reference it anywhere. And then clear contents gets called every time the button gets clicked by virtue of that actions hookup we just did. Okay, so that's a whirlwind of how I have limited time here, so I got to kind of move fast. That's how we would hook up a clear button. And our next example is going to be auto check success. And the reason I want to do this example with you today is because it shows how sort of composition can be really good with web components. Maybe it's sort of like every component that you've used, it's sort of, there's like an implicit, sort of reuse aspect to it, right? Like we define a component, use it multiple places, kind of one of the benefits of components. I think web components are also especially that way, and composing them together, sort of these general purpose components, can be really powerful. It sort of obviate the need for lots of JavaScript. GitHub maintains a bunch of little general purpose web components. Include fragment is one that will fetch HTML from a remote server and put it just in the DOM where the include fragment used to be. Clipboard copy element, which sort of abstracts all of the weird browser quirks around copying to clipboard. And when you click a button, it'll copy some text into your clipboard for you. Image crop element, which can crop an image, right? So all these cool sort of general purpose web components. You can see the full list, GitHub/GitHub-elements. The one that we are going to be using, though, is called the auto check element, appropriately enough. What this component does is it wraps a text input, and then whenever that input changes, it submits that value to the server, and then based on the response from the server, it'll emit start or success or failure or complete events. And one that's nice about it, it'll sort of like also handle debouncing for you. So if you're in the middle of typing and the request already gets kicked off, it'll cancel that previous request and do the next one, right? So all that's sort of handled for you by the element. So the way that we're going to wire this up is by sticking another parameter into our text field component, our Ruby component. We're passing an auto check src, probably some Rails path helper would be the value for that. And then in our HTML, what we're going to do, we have our auto check element. We've given it a source. Remember, this is not the ERB template. This is the rendered HTML. We have a data target in here. So we have a reference to the auto check element in our code. And then we also have a data target for the input. And our code probably just, it could be this simple, right? Like I'm not showing some of this again because of space reasons. But you can see we've got our two targets at the top. In our connected callback, we're adding an event listener to our auto check element, load start and load end. And when load start happens, in other words, when the person has entered some text into the text field, we'll show our spinner. And then when the request is finished, we'll hide the spinner. And we can do a similar thing with the auto check success event. We listen for this, and then when we get a response from the server, we can look at the text. We can also check the check the text. If there is text, we can set success. Otherwise, we clear the error that may have been there before. So as you can see, like not that much JavaScript here, right? We're relying on the auto check element to do a lot of the heavy lifting for us. And we're just subscribing to some events here and taking some really basic actions like hiding a spinner or showing a spinner or setting a success message, right? Like this is why and this is kind of my big pitch for web components. Like you probably don't need React, right? Like this is not even that complicated. You don't need a whole Shadow DOM rendering engine to do that for you, right? And then similarly for auto check error, it's a similar case. We just need to add another event and see what it's supposed to do here. If that name has been taken, it gives you a nice little error message. So you can see what we're doing here. Just the same thing, right? We're checking the error message. and setting that error message on the page somewhere. And I'm not, again, showing all of the functions you'd have to write to do this, sort of leaving that as an exercise to the viewer here. But you can imagine how that would look. Okay, that was a whirlwind web component tour. That's very similar to how GitHub uses web components. You can look at the full source code for the primer text field element, github.com/primer/view components. And thank you all for listening. And I'd like to return your JavaScript levels now to baseline.
Questions?
Any questions?
Hi, great talk. I had a question about web components and the best way to test them. Are system tests the way?
Oh, yeah. Yes. System tests for sure. I suppose, I mean, you can write, if you really want to write more JavaScript, which, let's be fair, nobody does. But if you did, you could also probably write unit tests for them and like using Jest or something. So like the way we do it in Primer is via system tests. So like that primer text field element, the clear button is tested with system tests. It's not tested with Jest. Yeah.
Whenever you show the view component, there's also JavaScript code. I'm curious how those are organized. Like, is it in the same folder? Is the JavaScript separate from the view component? How does that work?
Oh, that's a great question. Yeah. So the like with view components, right? There's like a Ruby file and there's a template or an HTML ERB file usually, and those two things sort of live together. Same root of your directory structure. We do the same thing with JavaScript. So if there is, so if it's, for example, primer text field, there's a text field RB file, there's a text field HTML RB file, and there's a text field element.ts file. Those are all at the same level of the hierarchy. And then we have like a primer.ts file that imports all of those and then exports them when you build the final bundle. Does that answer your question? Okay.
Seems like one of the most useful things about web components is just that it runs a function for every element. Wouldn't that be kind of easy to just write like a super lightweight web framework, and then you wouldn't necessarily need web components anymore? What is there anything else you find super indispensable about web components?
Oh, that's a great question. I mean, I think the biggest thing is just that they're just built in, right? Like I don't have to reach for a framework. I don't have to learn a framework. I can just use web components, right? There are frameworks built on top of web components that add a lot of functionality to them. So I didn't go over like templating at all. And I do find sort of the offering of sort of the web platform kind of lacking in this way. Like there's a template element. That template element doesn't get rendered. The idea being that you'll grab a reference to it, clone it, and then stick it into where your children would be to actually do rendering with web components. That's really clunky in my opinion. There's other libraries or other frameworks like Lit that I really like that sit on top of web components and offer more functionality around templating. So if you're looking for a framework, I would suggest that it do more for you than just give you what web components already give you, right? And if you don't need that stuff, then don't reach for it, right?
All right.
Okay.
Yeah.
Thank you.
Thank you. Thank you, Cameron. All right. And the next up is the person who, okay, according to Twitter, tried to park and cross the Bay Bridge. Yeah. So while Takashi is getting set up, I don't know. I don't want to steal anything from the talk. But yeah, can I just ask that? Like, how many people know about like YJIT and the whole initiative to speed up Ruby? Yes. Yeah. Mm-hmm. 3x3. Yeah. Oh yeah. Speed up Ruby 3 times, and like now it's gonna be what? Yeah, I guess. Yeah. Well, Yeah, Takashi, are you doing a RubyConf talk this year?
No, I'm not going to conference. I mean, conferences in the US, I only go to the RubyKaigi these days, but yeah, maybe next year. Hi, everyone. As she said, I accidentally took a wrong corner and crossed the Bay Bridge and took 1 hour to go back. Like I was here at 5 p.m., but took 1 hour to come back. Well, terrible. Right, so I live in Cupertino and like took 1 hour to come here and then took another 1 hour to come back. Anyway, I'm going to talk about YJIT today. So my name is Takashi Kokubun. On the internet, I use the Kokubun O in 0 as an internet username, and I work on the YJIT team at Shopify. Shopify has like 40-ish people team for like working on Ruby and Rails, like 24 Rails and 24 Ruby or something like that. And I'm also a Ruby 3.3 branch maintainer, so I cut the latest release for Ruby 3.3 basically. And I also maintain a bunch of template engines, ERB, Haml, Slim, and the current Haml 6 is what I rewrote from scratch. So I'm kind of the author of that as well. So yesterday I cut the release of 3.3.5, so please upgrade your production. I also announced that in the previous release, the Ruby release cycle used to be pretty weird. Like previous version was released like a few months after the 0.1 release, and then a half year later, the other release was cut after the next version of the Ruby. But now I changed so like I became the branch maintainer this year. So like I kind of changed the role, like every 2 months it's going to be a regular release. If something is urgent, I'm gonna just cut it earlier, but otherwise the next Ruby 3.6 is going to be released in November November 5th and 3.7 in January. And about YJIT, we have a bunch of folks working on this G compiler. Shopify authored the YJIT. The Maxim is basically the author. It's kind of backed by the idea called lazy basic block versioning, which is a PhD thesis of hers. And we basically, by the way, thanks to GitHub folks, not only Shopify, but also like a bunch of GitHub folks and other contributors work collaboratively on the YJIT. So thank you, GitHub, for helping us as well. And yeah, so as I said, YJIT stands for yet another just-in-time compiler. And when you say just-in-time compiler, it generally stands for something that speeds up your application by converting your interpreted machine, like virtual code, into the actual machine code that can be executed natively in your machine. And YJIT was merged in Ruby 3.1 first. But prior to that, CRuby had another compiler called MJIT, which was merged in 2.6. But the problem of MJIT was that it uses a C compiler to generate every single method. Like converting every single method into a machine code takes a C compiler process to do that thing. So it took like 600 milliseconds or like sometimes even more than 1 second to just compile a single method, which never works in production. So YJIT changed approach. We just scratched our own in-process assembler. We maintain YJIT in Rust, so it's kind of safely developed by that rich language. And like, so because of the characteristics, YJIT speeds warms up pretty fast. Like compiling a single method doesn't usually take even 1 millisecond. So like it usually doesn't impact your application performance by spending too much time in compiling your code. Currently, it's not enabled by default. If you just start Ruby application by just a single Ruby command. So you have to use -- YJIT option or use environment variable or this Ruby VM YJIT enable method to dynamically enable that in your process, which is available from Ruby 3.3. And the reason why I'm talking about this today is because I want you all to start using YJIT from like tomorrow, or if you're already using that, that's fine, pretty good. So how many of you are already enabling YJIT in production? Please raise your hand. Okay. So like for the rest of the folks, I want you to start enabling that tomorrow. So that's the goal of my talk. So these are the benchmarks we, Shopify team, crafted, thinking that these are kind of the production-ish workloads. For example, there's like Rails bench, and Lobsters is the actual Rails application that is like a imitation of the Hacker News website. And also like MailGem and HexaPDF, which is used for generating PDF, and like AV templates and Active Record, SQL for those folks you don't use the Active Record, or Ruby, LSP, Rubocop. So like a bunch of things that are used in production or real world use cases. And if you look at the graph, higher is better. So like the baseline, the blue one is the bottom, like interpreter performance. So our YJIT speeds up the real world code by like 50% or sometimes 100%. And in production, it doesn't go that well, but still gives a meaningful speed up. This is an article written last year. So like we have better numbers today, like 20 or sometimes 25%, but generally you can expect something like 10 or 20% speed up in the actual production performance. So this is a graph for our storefront, which is a microservice that is required to have a pretty fast performance. So like it's already tuned pretty well, but still gives this good performance. And this literally handles like tens of millions of traffic every second or so. So like it's a lot of traffic. And our team is providing, like working on this thing and providing value through this service and make money and still like share the benefit to you all so that we benefit from Ruby together. And a lot of folks outside Shopify are also using YJIT in production. This is also another like last year's article, so the information is kind of old, but today GitHub is also using that in production. So also thank you for using that in production. So it's pretty like reliable already, because like you also use GitHub, or at least, right? So you also like indirectly use YJIT through that. And good news is in Rails 7.2, it's kind of enabled by default too. So like this pull request was written like it generates an initializer in the Rails new, but later in the development of Rails, if I remember correctly, that was kind of actually changed to the internal initializer in the Rails. So even if you don't regenerate the initializers, you get the initializers that enable YJIT by default. If the Ruby is also like 3.3. So Ruby 3.3 added the YJIT.enable method. So it's necessary to upgrade your Ruby as well to get this benefit. So if you are using the latest Ruby and latest Rails, you might be already using YJIT in production already. If you don't use the latest version and you need to, if you need to enable it manually, then you need to use --YJIT or this Ruby YJIT enable environment variable, or this Ruby method inside like a Unicorn after fork hook or Puma after fork hook to do that dynamically. And so let's say you enabled YJIT in production tomorrow. The problem that might be likely to happen is memory usage increase. So YJIT speeds up your application, but it's not like for free. Like YJIT is optimizing your code using memory, machine coding memory. So it needs to at least allocate memory in the heap for generating the machine code. And besides that, we have to maintain some metadata to keep track of the machine code we maintain so that will be, for example, invalidated when the same method is redefined by something, and then we have to discard the code and redo from that point. So generally, we use more memory in metadata than the actual JIT code. And this --YG exec mem size option controls only the JIT code size. And by default, this is 48 meg. So if you just leave the option, the default as is, then it's going to use 48 meg for the JIT code, but also use 2 or 3 times more than that for the metadata. So you kind of need to keep that in mind. And if you use CRB, usually you have to use like Unicorn or Puma multiprocesses to parallelize your workloads in your single server. So each of their workers actually use that much memory. So like for estimating the worst case scenario, you have to multiply this option, like for example, 48 meg multiplied by the 4 or 3 for accounting for the metadata and multiplied by the number of Unicorn workers. So like it's a lot, but it's a kind of like a worst case scenario. If you want to optimize that, we also developed a reforking approach to share the memory across different workers, which is called Shopify/Pitchfork. It's a gem we publish in the regems.org. So you could use that, or just use the Puma's reforking feature to share the JIT code generated by an already live worker and then refork the workers periodically to share the JIT code so that you will not duplicate the JIT code across multiple processes. But if you want to just do a simple thing, then you could just use 16 as a mem size, and that's like a 1/3 of the current default, but at least it works for GitHub.com, so I guess it's a good option if you want to lower it. Also, if you need some help, we maintain the documentation under the Ruby repository, doc/YJIT/YJIT.md. So if you look for directory called doc, you can find the YJIT document there. And this is converted to docs.rubylang.org as well. So like there are like 2 important sections. The first one is for speed. So this is called performance tips of production deployments. This is basically for speeding up your application. And the other section is called reducing YJIT memory usage. As it says, it's for minimizing your memory usage. And as I said, I'm kind of recommending to lower the mem size here. But for speed, increasing is recommended. Yeah, but anyways, if you need some more help from not written here, you could talk to me on X, Twitter, Kokubun, or on Mastodon. I'm on the Ruby social Kokubun as well. And I'm also in the Nate's Performance Slack. It's private, but if you are there, you could also talk to me there too. That's about it. YJIT, so in short, YJIT production ready, please use that tomorrow and contact me if you are like uncomfortable enabling that in production. Thank you.
Okay, who's convinced? Everybody is convinced. All right. Questions?
With regards to the maximum memory usage for the compiled code, one of the slides said that it will stop compilation once that number is hit. Will existing code, for instance, maybe if you're running Rails prior to the initializer enable option, will unused compiled code be evicted from that, or is it just stopped from the duration of that process?
So basically, it stops compiling when the memory size or JIT code size reaches the limit. So if you use Rails prior to the 7.2, it's gonna, so usually you just enable YJIT at boot. So you're gonna start compiling the boot code, which is not using the actual application or benchmark code. But it's gonna basically waste the space, and you probably want to just enable it lazily, like in the initializer, or the best way is to actually enable that in the after fork hook in the Unicorn or Puma, which is executed after the boot, the fork of the multiple processes. And that way you could at least avoid compiling the code that's not going to be used after boot. Another option we have is prior to Ruby 3.3, we used to redo the entire compilation of the whole process when the limit is reached. So in that case, we discard the entire code and just redo everything from scratch, which is sometimes good for performance, but we thought it's actually harder to maintain or operate in production. So it's called YJIT code GC option, which is still left in the Ruby 3.3 as an option, but I don't recommend using it.
Okay, so there's not like a LRU or anything for executed code blocks?
Sorry, could you repeat that question again?
So there's not like a LRU cache or something for...
Right. So there's no such like collaborative caching in YJIT currently. This is for like maintaining the YJIT simple, keeping YJIT simple. And like from our like empirical experience, I mean, the 80% of the like, or 90% is actually executed in the pretty small amount of code. So like, even if you just stop compiling there, it doesn't actually matter. Like the GitHub uses like 16 meg and like we use 48, but like 36 probably doesn't mean anything. So like, that's kind of it, yeah.
More questions?
Hey, do you recommend doing any sort of warm up of the JIT code before you kind of like, let's say you're deploying on Kubernetes, like warming up those pods before you send production traffic to them?
Good question. So we did a lot of things. We tried out a lot of things. So like today's approach is, so we enable YJIT in only one worker, and we fork that to multiple other workers. So like some workers, I mean, not one, sorry, but a few of the workers are enabling YJIT from at boot, but others don't enable YJIT, but then periodically Pitchfork, ours like Unicorn fork, forks the warmed up YJIT processes into like multiple other, so they just, we evacuate non-YJIT workers after some like a period of time. And that's because if you just enable YJIT in all workers, what we experienced is on deployment, by the way, we deploy a lot. So like every 20 minutes or so, we deploy another thing. So like on each deployment, it took a lot of like CPU resources to warm up the process. So like that's why we try to reduce the CPU load and why compile that in the some subset of workers and then refork that to alleviate the load for warming up. But this is because we use Ruby master in production for the Rails monolith and the microservice for storefront. And like these days we had a kind of regression and comparison time. So we deployed that. But as of 3.3, it wasn't a problem. So you could just enable YJIT in every process and it should be fine. And hopefully we are going to fix the issue in 3.3 before it's released. So don't worry about it too much. Anyway, thanks to the architecture that doesn't take a lot of time in warm up, I think you don't need to worry about it too much. You just enable it at boot and then it should be fine. It's my idea. I mean suggestion. And if you still encounter problems in production, talk to me somewhere and I can help you.
What's next for YJIT?
So the thing we are developing right now is like, one of them is Redis Delegator for local variables. We already landed that in master branch. I authored that to, so big thing in 3.3, the previous release was we also use registers for stack operations that are pretty common in the virtual machine because the Ruby virtual machine is written in the stack virtual machine. So every operation uses the virtual machine stack, and now it's a register from 3.3, but local variables were still using memory, so that was slow in 3.3, but in 3.4, it's now using the registers if available. And that also means the local variables are like also arguments. So if you call a method, usually the arguments are already in some of the registers, and like method call overhead doesn't like have the argument passing. So we used to pass arguments in memory, but because we can use registers, if we just let the callee use the same registers as is, then we don't have like spend enough any cycles for passing arguments, which is much faster. And another thing I personally want to kind of learn in 3.4, hopefully, is inlining. It's not there. So like, we already have some sort of inlining. Like if the Ruby method is pretty simple, for example, like present question or blank question, it's already inlined pretty fast. Like also another feature in Rails 7.2 was we have some specialized method definition, which just is a fast pass like false or true for some classes. So in such cases, YJIT inlines those Ruby methods and makes it pretty fast. But if the method is complicated, we don't handle it in that inline way. So so the next big thing would be to support compiling pretty much more complicated thing than just true or false for speeding up those complicated stuff, and enable cross-method optimizations like constant folding and propagation of the value and like computation at the compile time. So those things are what I think is the big thing for YJIT, but it's not there in master branch yet, so stay tuned.
All right. How about this? We will thank Takashi now, and if you have more questions, let's take them into the break. And thank you so much, Takashi, for the presentation. And
thank you.
Yeah. Yeah, definitely. Thank you to the whole YJIT team for speeding up Ruby. And I remember we spoke with Ufuk about this, and he asked, okay, what do you think is like how the goal can look like, what the goal can look like for the YJIT team? And I said, well, when Ruby engineers don't have to reach for Go for performance, then I'd say that's the huge win. Yeah. So yeah, good job. Thank you for doing this. All right. So with that, we're going into a short like 15-20 minute break, and I will so yeah, let's chat, let's discuss this, and we'll get back together here we'll begin with the open mic. So prepare your announcements and questions, and then we'll have Brad's short presentation and 2 more presentations on architecture and concurrency in Ruby. So see you here. All right, let's start gathering back here, and we'll be starting in a few minutes.
So I just do the content that you have now, right? But sometimes I was like, So I'll be able to connect my laptop, right?
Yeah. You're here.
Oh, yeah.
Yeah, I didn't see before.
Do you want to move over here or?
Oh, thank you. We gotta start. We gotta do it. How do I do this? Yeah, I'm gonna down. No, I'm gonna go. Oh. All right. And you know what's next? This is the open mic. This is the open mic, and the open mic is for you. By the way, the light here is blinding for some reason. If you want, yeah, so this is the open mic is for you to share your announcements, your questions. Maybe you're looking for a job, maybe looking to hire, maybe you have a question, maybe you want somebody to help you with some problem, maybe you want somebody to help you, for example, come up with an idea of a talk proposal for this meetup. How about this? For this one. still have a little bit of time until people kick us out at 8:50. That's going to happen, by the way. So, all right. I know it's perfect. So please tell us your name and yeah, go ahead.
Absolutely. Thank you so much. Hi, everyone. I'm Meghna, co-founder and CEO of GoCodio. I have one question. So what we essentially do at GoCodio is help developers automate the entire software testing. We are super ambitious. We want to help devs build cool stuff while we take care of testing. How's Ruby going to span out? Because we are live for Python, we are live for JavaScript. So I'm curious about Ruby. So that's why I'm here asking questions. So raise of hands if you think we should probably look at Ruby very seriously. Awesome. That's a significant point. So if you think of any suggestions, any kind of an idea in this space, please feel free to reach out to me and speak with me. So yeah, thank you so much. Yes.
Okay, so sorry, I have a follow-up question. What kind of testing? Tell us more.
So we are currently live for unit tests, but what we are thinking is the entire code level testing, right? White box software testing. When I say that, I'm looking at the code, trying to analyze the very tiniest piece of code at the unit level, and from there, how exactly each units interact with each other, the integration level. And from there, we go about looking at the functionality level. So we are currently live for unit testing. So yeah.
Is it open source?
Not really. I'm sorry, but yeah, I definitely would like to kind of contribute there. So if you have any tips, please let me know.
Oh, yeah, we can talk.
Absolutely.
All right,
Awesome.
nice. Thank you.
Right. Thank you so much.
Thank you. Who's next? Yeah. Okay, I will not pressure you today because we have a big agenda. And like I said, people are going to kick us out of here at 8:50. But I know everybody is an introvert, me included. Yeah. Adarsh, you next.
Hi, my name is Zach Mariscal, and I work for user testing. And I just want to make a service announcement that there's a great conference occurring called Rocky Mountain Ruby. Who here has heard of it? Great. Well, if you love Boulder, Colorado, if you love Ruby, it's a great intimate feelings. I'd say semi-similar to this. If you really enjoyed this experience, you'll enjoy Rocky Mountain Ruby. Google Rocky Mountain Ruby. Thank you.
By the way, I happen to be speaking at Rocky Mountain Ruby. So you should totally come. Yeah, go before, while Adarsh is.
Hey, I am Jamie Alessio. I am an engineering manager at a company called Babyless. You may not have heard of us. We have millions of users, and we are a Ruby on Rails app. We are hiring at all levels for Ruby on Rails full stack engineers. And I am personally hiring on my platform team to support the production app using things like YJIT and all that good stuff. So come find me if you're interested in any of that.
Perfect.
Hi, I'm Adarsh Pandit. How are you all? I'm sure you have seen me before, but I'm going to go through my same spiel that I normally do. But I just want to introduce myself. I'm the executive director of Ruby Central. If you don't know, Ruby Central is a nonprofit that has been around since the early 2000s and originally supported RubyConf and RailsConf and puts on those conferences. And as of the last 5 years, we have administered Bundler, which I'm sure all of you have used, as well as Ruby Gems and rubygems.org. And so we recently have been taking donations from different organizations to improve security. So all of your security is improving. We're doing all kinds of different secure things that I'm not going to even mention because I'm not an expert in package management security or any of that stuff. But if you're interested in that kind of stuff, I'm happy to connect you to our team. I want to invite you all to RubyConf in Chicago. It's going to be awesome. It is November 13th to 15th. Tickets are on sale now. They are our little graph for like how fast they're selling versus history seems to be going up faster. So get your tickets now while you can. In terms of speakers, we have some amazing keynote speakers, some from the Bay Area. There's this guy, I don't know who he is. Nadia, if you happen to see her at RailsConf in Detroit, gives an incredible talk. Brandon Weaver is from here in the Bay Area, and I don't know if he's here, but he does lemur-oriented talks and hand draws every slide. Oftentimes he does like over 100 slides, and they're all completely hand drawn. He does all the storyboarding, and like he's been texting me pictures and samples of what he's been drawing, and it's phenomenal. Drew Bragg runs Philly RB, and Nick Means also is like a incredible speaker who oftentimes talks about airplanes, which you think would not connect to software development, but you'd be shocked. So consider that, and Chicago's a great place to go. And also we're looking for sponsors. So if any of your companies are interested in sponsoring our production for signage and all that stuff, those deadlines are coming up. And the last thing to build on the Rocky Mountain Ruby mention, I don't know if you guys are all aware, but so we're in the community development world, and one of the things that we are trying to help promote is rubyconferences.org. If you know much about it, it's just a Jekyll site. You can open PRs to it, and it has all of the conferences that are coming up all over the world. So if you're looking for vacation, work-related vacation, maybe you have some like educational funding you want to spend at work, you can go to cool places like Cape Town, South Africa, or Warrnambool, Victoria in Australia. Sorry, Australia. But it's a great resource. I highly suggest you check it out. There's also something that you can, I suggested and somebody else built, which is there's an iCal feed. So if you want that on your calendar for planning purposes, you can add that. We also added recently this meetup schedule. So let's see if we're up here. I think it's already over. But at any rate, all the meetups are here. So if you are on the live stream and are elsewhere and you want to go to a meetup, this is something you consider. At any rate, thanks, and come chat with me after. Bye.
Okay, nice. We praised rubyconferences.org twice during this meetup, which is cool. Brad, I think it's time. Yeah, I know many people wanted to do the open mic, but let's do it next time. Right, so this is Brad Gessler, and he's doing an announcement, or what's the word?
An overview of a project I've been working on for the past few weeks. All right, this is what it's called, Terminalwire. I tweeted this about a week ago. I think a few folks have seen this. Let's get a show of hands and see who's seen this on the twits. Cool, all right, I'm gonna kind of run through that, a much better demo this time, including hand-drawn stick figures. There's a lot more about me here on the twits, so if you want, check that out. If you're wondering what is Terminalwire, it's awesome that I get to present this to a Rails crowd and a Ruby crowd, because we get it. We're all about compressing complexity. So Terminalwire is kind of like Hotwire for command line apps. And I'm gonna kind of illustrate what I mean with Sticky McStickface here. So everybody say hello to Sticky McStickface. Hi, Sticky. All right, so Sticky wants to ship a CLI for LitHub. How many of you have used the LitHub CLI? What about the GitHub CLI? All right, so I'm gonna talk about how you might build LitHub based on how GitHub works. All right, first thing you do, you set out, you build an API, probably some kind of JSON API. You can see up here, I actually have some handcrafted JSON in case you're wondering what that looks like. And then Sticky has to code an API client in Golang. And Sticky's not happy because Go's not as expressive as Ruby. But he just plows forward because Go is a great CLI tool. And then after all that, he has to do a bunch of integration testing to make sure that the CLI that he wrote in Go works with the JSON API. A lot of moving parts though. All right, quick question. What has Sticky McStickface not done yet? Just shout it out. Ship? He shipped. The API is out there. He actually has not worked on the CLI yet. He's just worked on the API server and the API client. All right, there's the answer. Sticky has not built the CLI yet. Finally, Sticky builds the front end that sits on top of the API client that lives inside of the CLI. Go, Sticky, go. Sticky's done, right? Nope. Now Sticky has to figure out, okay, well, I have these binaries compiling. How do I get this out to the world? How do I tell people to deploy it? And don't forget the docs, Sticky. All right. So there's a lot of moving parts there to ship a CLI. You have to build an API and you have to build a client, and there's a lot of moving parts. The hard part, though, is whenever Sticky McStickface has to make a change to the command line application. So he painstakingly updates the API. He has to, of course, have versioning. He changes a few things. Sticky's not getting very happy because now he has to do some more manual and automated integration testing. And then he had to change the API. So now Sticky McStickface has to figure out how to go out and deprecate all the old Go clients that were put out there. Sorry, Sticky. All right, anyway, Sticky, he finally prevails. He ships the new API and the new client, and everything's good. He deprecated everything. Just kidding. Sticky gets an email from Eggy McEggface that he broke the API for their biggest customer. What does Sticky do? Does he roll back the API and break the new clients, or does he make sure that the old clients work and rolls back the API and save the day for the new customer? Sorry, Sticky. The end. All right, so to put that into kind of more of a classic picture that you might see today, if you're building a CLI client, kind of like what Stripe or GitHub pushes out there, you're probably going to build something that looks like this. You start with the server. We're kind of familiar with that. You have a Rails server. Maybe you put a JSON API on it. And then you're like, okay, I'm going to build a CLI. Maybe you'll use Golang or something like that. You have to make an API client that can talk to the server. And then, of course, you have to have the terminal and do all that stuff. So I don't know when it happened, but one day I was thinking through this and I thought, well, what if we just deleted the API and get rid of all that? And we replace it with what command lines already have, which is standard IO. There's a few more things beyond standard IO that we'll get to. Oh, all right. So I'm quickly going to jump into a demo and kind of show you what it looks like inside of Rails. So this is actual working code right now. Can everybody see at least that stuff? Or should I zoom in? All right, good. All right, so we'll start with the command line. We just have this thing called bin tinysap. And if I run it, you can see there's just one command in there, and let's see what's actually in this binary and what's going on. So a few seconds, you may have immediately noticed like, whoa, there's a lot of latency going on whenever you fire up that CLI application. Anybody know what's going on here? In my prototype, I'm booting up the entire Rails application. So most of the latency is coming from that. I'm booting Rails so that I can grab this and connect to it via WebSockets. Whenever this thing finally goes to production, we won't have to boot Rails, so it should be pretty quick. Anyway, if we run the binary and we want to start adding features, I'll switch into Rails here. And I don't know if you can see this, but I have in the app CLI folder, this is just Tor or Thor. So let's add a version feature to this. I hit save, and then I want to run that again. We see version is there. And what's kind of neat about this is what I didn't have to do. I did not have to go out and change an API and coordinate all these clients and do all this kind of crazy stuff. So let's go ahead and have a feature where we can open the website. So we run that. Again, this is just Tor or Thor. So if I launch it, and this is where things get a bit different than like say SSH. I don't think SSH can launch websites. So here we go, launch my website that I'm integrating with. And very quickly, I'll get into login. I think kind of the most straightforward thing for login is to just ask for a username and password. But as we know, if you've used Stripe or GitHub, authorization and authentication has gotten quite complex. So you probably want to open a web browser. So if we check out this code, which is not production ready from a security point of view yet, I am opening a URL with browser launch, and then I'm gonna listen on this pub sub channel, which side note, Action Cable is actually a really good pub sub framework. If somebody wants to extract that out, it would be very easy and I think a very interesting project to take on. So anyway, we're going to open the browser and then we're going to wait for a message to come in, the authorization message. And then this looks kind of familiar with a controller where you're saying, hey, the current user is equal to this. Except in this case, the current user is actually persisted on a file on the user's computer. So if we run that, log in, we get this kind of approve, deny, CLI thing. And if it all works, we should see, oh, we want to have like a who am I? So that won't work because we don't have it yet. But I've built that here. So we'll uncomment that. We'll run who am I? And oh, I got it right. Brad@brad.com. So I was able to ship, what, 4 features for my client without changing any APIs. It was all just done over standard IO and a few other channels. And I'd say that saves a lot of time. We didn't have anybody from sales emailing us saying, like, hey, you broke the API for our biggest customer, revert it. All right, so where is this at right now? I shipped a prototype. I threw a video out there. Next steps, I'm going to get this thing working on Rails. I want to have a good Ruby client and a Rails server to get out there since everybody kind of gets it in terms of compressing complexity. Hopefully that ships in a few weeks. And then after that, if all goes well, I'll ship like a Go front end for this thing so that it can be distributed beyond people who don't have Ruby installed. And I want to make this work for more servers. So if any server has like a command line application library in it, you can drop Terminalwire into it, just hook into the standard IO and then run it on JavaScript or F# or whatever it may be. So yeah, if this is something that you think you'd be interested in, here's how to get a hold of me, or just find me here. Thank you.
Pretty awesome. Thank you. Thank you, Brett. Maybe one question. Okay. Yeah. That's pretty cool, Brad. Yeah. Okay. Thank you. I wanted to ask something, but maybe I'll ask you privately. You know, I don't want people to know.
Question over here.
How does the browser.launch thing work, or is that part of the secret sauce?
It's not really secret sauce. I just figured out, I think there's a gem called Launchy, and the prototype just calls into Launchy and it says, hey, just launch this URL. And that's pretty much it. Kind of conceptually, essentially what I'm building here is just like a web browser that runs in a terminal. It's not going to have graphics and all that stuff, but there's certain things that it should have, including security features. So for example, right now I'm playing around with, okay, well, how does the server write files to the client? Can it delete files from the client? Obviously, you don't want the server just deleting or accessing any file on the client. So there needs to be some kind of entitlements on it. So I'm hoping for the end user, if you install a terminal application, you'll have these assurances of knowing like, hey, I have to grant access to Terminalwire to access these files. So there's a whole layer of security similar to a web browser that'll be built into this that just adds more safety for users than what they might get from a command line application today.
Oh, I know what I want. What to ask? Is it using SQLite?
Pardon?
Is it using SQLite?
SQLite? No. SQLite is great though. I don't even know. Actually, it's not running a database yet. There's no database. It's just a Rails application, and I don't need a database yet, so I'm not persisting anything. But it doesn't matter. Use whatever backend you want. SQLite, Postgres, whatever.
Oh, all right. All right. Thank you. Thanks, Fred.
Yeah, thanks, everybody.
Okay, and the next one, the next stop is Kamil. So Kamil, are you gonna share something about your company, right? Yeah, all right, nice. So I'll let you talk about it. Yeah, what a few words. So Kamil just moved to San Francisco 2 months ago. Welcome. And you see, when you move to San Francisco, you have to do something. Either talk at a meetup or run a meetup. You gotta do something. So yeah, welcome. And we're gonna learn something new or something opinionated about Ruby architectures.
I would say. Okay, hello. My name is Kamil, and I'm going to talk about different types and flavors of Ruby on Rails architectures. A little bit about me. I work at Plane, which is a Y Combinator startup. We do payments in HR space. We use Rails, Ruby, all of the standard stack, which is why I'm here. I also co-founded several startups myself, but now I'm just working at this company. I wrote a few books, mainly about testing, something about product management, and I also blog. As was said, I just moved in here, so this talk it won't be anything groundbreaking, I think, but it's kind of like my way of saying hello and getting to know people and how you think about things that I'm going to talk about. Okay, so I'm going to start with something really, really basic, vanilla Rails, right? So this is going to be kind of like establishing a baseline to what I'm going to talk about later, right? This is very simple. We've got something like a model. This one is actually taken from the newest app by 37 Signals, Writebook. This is one of their once apps that they published. We've got some relationships, some concerns, callbacks, right? Simple stuff, everybody knows this. The models are rich, right? That means that a lot of code domain logic goes into them. And what we use is concerns to extract this and maybe manage this so that it's easy to read, stuff like that, right? Here, simple example, some property, role, extracted into the concern, but we can also do something more complex. I thought that this was fitting since this is GitHub HQ, right? So here we've got some repository model with a pull concern, and we connect to the API, pull the repositories, and we also pull some commits. My point is that you can do complex stuff with this. It's not that you can just do simple stuff. This is the basic approach, right? The default one, but it's not that it's only for the simple apps. Everything will work here, right? And one problem that you might already notice with that is that what if we have some code that maybe interacts with multiple models and it doesn't belong to any of them, right? So the answer is here. We create a separate object that is a pure Ruby object, and this Ruby object becomes part of the domain. In this example, this is a first run model that uses two models, right? And it just becomes the part of the ubiquitous language of the domain that we're modeling, but it just lives in the domain space like everything else. The main advantages of obviously that it just works, right? It's the default approach out of the box. Everything is easy to set up and use. Okay, so now something more complex. And this is a little bit connected to what I just talked about. We have those transaction scripts, like the first run service that I showed you, right? And in this case, I'm going to develop on this and show something more complex. The idea is that for many developers, this basic setup, it's not very, well, it's like puts too much responsibility on the models, right? So they want something that is more, that has more refined abstractions, something that is easier for them to work with, more advanced. And they probably end up with something like this, service objects, form objects, view components, representers, right? And this is actually the approach that we're using at Plane right now. And we even developed a custom internal library to support it. And our use cases, I'm going to show you. it in a second, but it's not unfortunately, it's not open source. But if you're looking for something like this, then there's a lot of stuff that does similar things. For example, the Trailblazer library, or maybe the dry RB stack. You can very easily replicate this and start using it basically tomorrow, right? Okay, so let's start with something simple. We define a service, we give it some params, we perform it, right? By default, all our operations, that's what we call those service objects, they are transactional. So everything that happens in perform is wrapped within a transaction. And we can also handle side effects using the after commit block, right? So we can publish some event, we can maybe send a Slack notification, maybe email. And in this example, I explicitly turn off transactional as true, right? But if I wanted to turn it off, I would just change it to false, and basically that's all built in, right? We handle it out of the box. Another nice thing is that you can execute those operations asynchronously. So the only thing that you have to do is add an async prefix to the chain when initializing the operation, and it just works, schedules an operation. You can also like add a delay, stuff like that. It's especially useful when you want to avoid boilerplate code, like having a worker that the only thing it does is trigger a service object, right? It's kind of useless, so we can do it this way. Okay, next. Another nice thing that we do is we have typed params. As you can see here, there is a struct called params that defines the attributes, defines the types, and it also allows you to perhaps set some defaults. This is used based on the dry struct gem, and generally the dry RB library set of libraries is very good. I recommend it to everyone here. We like it at plain and use it a lot, right? So the params are typed, but also the responses can be typed as well. This is nice for documentation, right? So you have very easy API to use. You know what to expect, but also some additional security when it comes to running this code and being sure what's going to be the result, the input and the output. Another nice feature is that we added recording operations. So you can turn it off entirely. You can set, just record the input. You can record the output. By default, it's enabled for every operation. This is going to be useful in the next slide. But for now, I can say that this is also a very nice feature when it comes to debugging, but also maybe some compliance stuff. You need to have a log of everything that goes on in your system. Internally, we use it a lot, but it also enables to do something like this, right? So you can perform an operation once and only once because it's recorded. You add the key in the once method, and then every time you retry this operation, you get a saved result every time. So you can just guarantee that nobody will execute it twice. We also added support for remote operations. In this case, this is a server code sample. You add a remote method at the top, and this defines a queue in RabbitMQ for a RPC that is going to be executed, right? And now the client, you add the same remote method at the top. You define the queue, the same one that we used in the other operation. Then in the second code sample, you add the remote prefix to the chain when initializing the method. Then it's just, handles the complexity of doing the code behind the scenes. You can just enjoy having the results. And again, the params are typed, the results are typed. So it works very nicely with this approach. You can use it for something like, microservices, if you have them, right? You want to handle something synchronously instead of events. This is the way to do it in our framework. And now the pros and cons. Pros is that it's pretty powerful. You can do a lot of things with it. It's easy to use and it's flexible. And we didn't stray too far from the default Rails way, right? It's still basically plug and play, like a plugin, like an extension of the default way. But the problem is that you risk having an anemic domain model, which means that in the previous approach, there was a risk of overloading models, right, with too much responsibility. But in this model, for me, it's usually so easy to write these operations, right, that you can just overload them with too much code and too much responsibility. And now everything else, suffers from it. So you have to still keep that in mind and make the domain nice. Okay, the last one is domain-driven Rails. This is going to be a little bit more complex, but I'll try to simplify it for you. Okay, so as I said, in the previous two approaches, we didn't stray from the default too far, but some developers have a lot of issues with the default Rails way because they say that it introduces too much coupling, that things are too tightly coupled, right? And this makes changes difficult. And this is especially happening in companies that are working with using agile product management practices, right? Because sometimes if you're not careful, these agile style systems, they're kind of scared of any big design up front. So we just end up with spaghetti code if we're not careful and we're not doing any refactoring. Okay. This figure is from a book called Architecture Modernization. This book was written back by Nicieja, and I was the technical editor for it. So as you can see, strongest coupling from weakest to weakest coupling, right? And unfortunately, I would say that Rails goes to kind of the top of this diagram, right? So sometimes cascading changes can make updating the system risky because suddenly we have to refactor half of the app, right? If we're not careful. This is the book. If you're interested, I recommend it a lot, but I guess I'm not objective because I work on it. But if anybody's interested in stuff like that, especially on working with big legacy code bases and maybe trying to update them, it's very good. Okay, so now let's try to apply this and maybe take it a little bit to the extreme. And let's try if we can decouple as much as we can and what's going to be the result. We'll begin with using a command bus and also using a command. In this case, this is an ordering add item to basket command. We give it some params. And then we configure the command bus to have some handler, right? And the benefit here, and this is the first step of this decoupling process, is that we can now have multiple handlers from different subsystems, and those subsystems don't have to be necessarily Ruby or Rails subsystem. They can be whatever they want as long as they follow the schema of the events and the commands, right? And those subsystems can either issue the commands or they can react to commands, right? So it's very decoupled. And we basically, like on the previous slide, I said, we decouple what is done from who does it, right? Now we issued the command. Well, we have to react to it somehow. Here's the handler. What it does, it builds something that is called an aggregate root, and then it adds an item to the order. And for the purpose of this talk, you can think about aggregate roots like domain models, but they are not active records, right? In this case, as you can see, our command initializes the pure Ruby object order here. It also adds an item, and the item fires an event. And then we have this concern called aggregate root, which is provided by a gem called Rails event store, which I'm using in this code samples. And then you can see that based on the events, we are actually building the state of the object, right? So the history is created. We've got the history of events, and each event changes the object, and then something new is done to our order. Now, you might think, okay, we've got those commands, we've got those non-active record models. Everything is decoupled, everything happens outside of Rails almost, right? But how do we actually use it in views and other parts of the system? The answer is that we must build a bridge, and it's going to happen using the same paradigm. So we build a handler. This handler reacts to an event, and it creates a record using this new class that is called the read model. The read model is optimized for whatever we want to use it in the actual application layer, because it's now decoupled from the domain layer. As you can see, it's a bit of a stupid example here, but the optimization here is that the status is a string, and it can be just directly displayed in the view. You wouldn't do it like this in production, but I just wanted to include something, right? Okay, pros and cons. So the first advantage is that it's very suited for event-driven programming models. So if you use stuff like microservices, right, this will fit right in. It's very reusable, right? In theory, we could write something like a billing domain and just copy it from app to app, right? Don't have to write it twice. It's not coupled to anything, so we can just copy and paste it and then write our read models separately and use them in the application layer. And in theory, it should be non-brittle because of its loose coupling, so it should be resistant to change, right? But the problem is that actually, if you do stuff like, for example, you misdefine model boundaries, then it's going to be a problem, right? Because you will have to rewrite it, and it's a continuous exercise when it comes to getting domain boundaries right. So it's not really true, but if you do that like extremely wrong, then you run into a risk of creating a distributed monolith, and you just got like the worst things when it comes from monoliths and the worst things when it comes from event-driven programming, right? So not great. And as you could see also, this is very complex. Like this use case was pretty simple, right? Adding an item to a basket, but we had multiple classes, several new concepts. This is very non-standard when it comes to Rails, so you cannot expect that it, like, I don't know, some popular libraries will support it, right? So you're kind of on your own, and you have to know that. And the reality is, like, in 80%, maybe 90% of the cases, CRUD is almost always good enough, right? So this is the default architecture that we use, and it's that for a reason. If you want to use something like this, I would actually recommend that you think about it very, very deeply. We did that at Plain at some point, and we ended up rewriting everything to a simpler approach. So sometimes it can be not great. But I wanted to show you because I come from Poland, and in Poland, people are crazy about this for some reason. So it's kind of, I wanted to bring it to you, maybe share the pain or something like that. I don't know. Okay, and that's everything. My question to you is which approach do you prefer, or maybe a different one? I'm open to discussion. I just wanted to show you what I know, and now I want to know what you know.
Perfect. Also, folks are hiring.
That's true.
Yep. All right. Questions? I'm almost scared, you know, about questions after your talk. I don't
after
know.
the last part, or
yeah,
what?
because it's very like it's very dividing.
It is. It is.
So
I wanted to start the war, stuff like that. just say hello and then fight. There are some questions there.
Thanks for your talk. I'm trying to figure out how to formulate this question. So one of the approaches you talked about was service objects, right? Or something
Yes.
close to that. And at least in the circles that I run in, service objects have kind of been a polarizing topic, last couple of years at least, where advocates of them say that, they help decouple, as you were saying. And I also really liked, by the way, your concept of not only refactoring controller actions into service objects, but also wrapping APIs with them, like remote, procedure calls or whatever with an operation. That's also really cool. But I think that the detractors of the service object paradigm, I can't call it a paradigm, technique, say that that really all of that logic should just be part of your domain model, right?
Yeah, that's exactly what I was talking about when I mentioned the anemic domain model problem.
Right. And so I'm wondering, like, what you think about that. Do you think having a service object layer is a good idea? And if so, what do you say to the detractors of the service object?
Yeah, so
technique?
I actually agree with that point that the enemies are making, right? And I actually, like myself, I started experimenting with like coming back to the default Rails approach and maybe adding some other stuff from both of these approaches that I was showing, the more advanced ones, let's call them that, right? Because it is a kind of a problem. Like you're moving a lot of responsibility from the models and from other layers, because some of this stuff maybe should be in controllers as well, right? You could argue that. And you're putting them into those service objects. For us at Plane, this kind of evolved organically, so it's driven by use cases. It just works best for what we do and what are the requirements. And I kind of tend to assume that this is the correct way of evolving architecture over time, because there is no golden rule, right? But the risk is that, I don't know, you could end up with models that their only responsibility is storing data in the database. And this is like an anti-pattern, I would say, right? So you have to be very careful and very mindful of what is going there and what is going in this layer. Yeah. So I would kind of answer like this.
So in your approach to service objects, do you prevent client code generally from accessing the active model, the active record models directly and just use them for persistence purposes, or like because of an implementation detail behind the service? Or do you let the controllers reach out and grab, whatever active model object directly and manipulate it?
Yeah, so we still try to have a lot of responsibility on the models, but it's more like limited. And I would say that the guiding principle is if we have a transaction script, so something that can be divided into steps, then this is something that belongs in this service layer. That is kind of a way that we do it. But I don't think we limit access to, there are a few cases when we actually prevent you from like making the changes of the model yourself, because we've run into several problems with that. Like the process may be so complex that you, for example, changing a compensation of some worker in our system. This means that this has to be propagated to multiple subsystems, like updating the payments and so on, so on, so on, so on. So there's a lot of side effects. And if you do it yourself, you're probably going to forget about something. So we just, blocked it from updates, and we say, okay, you have to use this, right? Because we've run into problems so many times. But it's kind of an exception.
Hello, thanks for your talk. And I'm a big fan of dry beat as well. how do you feel about interactors and like the whole paradigm about interactors? The one thing that I really like is that they're not actually service objects, and they're more like, I don't know, like list that you can interact with.
So I actually never used that part of the stack myself. So I don't have a lot of experience with it. Sorry for that.
No worries. Thank you.
Yeah, you can make a presentation about them though.
That's true. Like part 2.
All right, folks. Okay, I think we're ready to go, to let Kamil go. But yeah, thank you for the talk. And I hope we'll hear more ideas about kind of design decisions in big Rails, growing Rails companies. They are, you know, I think we can keep discussing this. We should be discussing this all the time. Because it's not, there's no, like you said, no golden rule, but like it's evolving. All right, so we are ready for our final presentation today. Konstantin, please take the stage. So Konstantin is super experienced. And while he's setting up, I'm going to say something. So first of all, Konstantin used to be a CTO in a bunch of startups. Now he works as a staff engineer at Academia.edu. Have you heard about this? Should we say it's a startup, like just a little bit later stage?
I mean, it's been around for about 10 years, but
yeah,
it's a startup.
Yeah. So turns out
there's a couple of my colleagues in here in the audience, and our VP of engineering is here to already take your resume.
Yeah. Nice. So it turns out back in 2016 or something like that, I was building a startup, and I was learning Rails, by the way, at the same time, and building with Rails, of course. And the company that you were the CTO of was essentially our first customer, Vanilla.
Vanilla, yeah.
So yeah, the startup was about like hiring engineers, like a platform for that. So yeah, that's why I was so surprised when I saw the very familiar. You know, when you have your first customer, the logo of this first customer is like ingrained in your brain somewhere.
Well, thank you. Yeah, we were also like the third customer of Fastly. Also, my name is like literally I'm the only one on the internet with that name. Which can be a blessing and a curse, depending on who you ask. So thank you so much. I'd like to talk about concurrency, my favorite topic in Ruby. I've been doing Ruby for 17 years, and for a very long time, I felt very short-handed as far as concurrency is concerned, as I'm sure many of you have too. Because why? We have GIL, we have global interpreter lock. So we'll talk about how that's changed, but before we do, quickly, who am I? Thank you for that introduction. I've been basically doing software all my adult life. And I've been doing Ruby since 2007. I've got a bunch of gems written. Not all of them are popular, as per usual. I currently work at Academia, and we are hiring. So I will have another slide on it later. And these are my very brief links. I will show them at the end as well. Oh, yeah. So really quickly, I want to kind of step back a little bit and talk about some of the core concepts that are part of the concurrency landscape. So first of all, kind of a necessary understanding of difference between concurrency and parallelism. And we often talk about concurrent things, concurrency, and then what is it really? Well, the truth is that concurrency is actually just a perception of multitasking, but could be real multitasking, could be real parallelization. But the truth is that we don't really specify what kind of concurrency that is. We just mean that it looks like things are happening in parallel, but concurrency doesn't necessarily imply that. Now, parallelism, on the other hand, does imply that things are happening actually in parallel. And so it's when you have multiple tasks running at once, and they can be executed simultaneously on a CPU. And so to kind of clarify this landscape a little bit further, I want to just sort of touch base on what Unix process is. Hopefully most of you already know what this is. You run a program, the operating system creates a block on memory. It contains program's code, data, set of resources required, just file descriptors and so on. A program, of course, can request more dynamic memory. As it runs, it may have a single thread, or it may have multiple threads inside. So threads within the program typically are units of execution that can flow at the same time as well. There's two different types of threads that people talk about. There's green threads and there's native threads. And we haven't really talked about green threads in a very long time. But when the first Java JVM came out, they had the green threads until version 1.3. What that meant is that JVM actually emulated threads. They didn't really properly schedule threads on operating system schedule. It did it on its own. And then in 1.3, JVM switched to native threads, and lightweight Java processes are now the same as OS threads. And native thread, of course, is the actual unit that CPU can switch to and pass operation to. And that's done at operating system at the kernel level. So it's all about who is scheduling it. So if we're talking about multi-threaded program, let's say we have a single process. Within this process, there could be any number of native kernel threads. And a single Ruby 2 process, I'm talking about version 2 Ruby, always ran on a single logical CPU core, regardless of how many threads you have in there. But threads were useful even in that case, because sometimes we do I/O, and in a typical Rails application, as you're processing web requests, you may be spending half of your time doing Ruby. Maybe it's rendering your HTML or JSON, and half the time potentially talking to your database, your caches, your file system. And that creates this sort of waiting on I/O time that could be used by another thread to perform those CPU operations. So that's why if you run Puma, you're probably running 2 or 3 threads at the minimum, so that you can saturate your CPU. Why is it important to saturate a CPU? Well, you have resources, hardware that you're paying for. If you're not saturating your CPU, if your CPU is not at 70 or 80%, if it's sitting at 20% consistently, maybe on one core, you're overpaying. You're not actually using what you pay for. So what you want is, ideally, if you're paying for a multi-core server, you want to see every core working, hopefully somewhere around 70 or 80% saturation. Otherwise, you're really wasting the hardware. So the other way that we used to deal with multi-core systems is the multiple process model, where you have a single master, like in Puma, and which creates multiple workers. Same with Sidekiq, although in Sidekiq you have to pay for the enterprise edition if you want to run multiple, unless you use Sidekiq Pool Ruby gem, which is free, which does exactly the same thing. And so Server Manager, which started workers, processes, even though it does copy and write, which means that unless the code changes in the fork process, it remains shared with the master. It still is a pretty expensive operation compared to threads. And so if it's a long running process, that's okay. If it's constantly killing processes, that's really not very efficient. A good example of a server that does it really well is Postgres. It does fork a new process for each connection unless it has some that are idle. And that's because Postgres actively uses shared memory really well, shared buffers. But the reason threads are so useful is because while they have a lot of memory that is unique to the thread, they also have a whole bunch of memory, all of that horizontal lines that are actually shared across all threads. And so overall, you end up using a lot less memory. And context switching in this context is basically when a Unix operating system goes and says, hey, you've been taking too much CPU, I'm going to pause you and pass the baton to the next thread or next process. And sometimes context switching is voluntary. It's when the thread or process says, hey, I did my part, I'm going to pause and let someone else be on CPU. Or involuntary, which is when basically operating system has to terminate or interrupt the process in order for other processes to continue. And you can often observe the number of context switches on operating system using VMstat or other tools. And if you're seeing that a particular process is causing enormous amount of context switching, that is often a sign that you have too many threads configured. This is just a small diagram to kind of show you the time running from top to bottom, even though the bottom arrow is a little cut. You sort of see how the threads on a single CPU core in Ruby 2 could never really truly run in parallel. They sort of like pass the baton and then they run. But that happens so fast that to us, it looks like they're running at the same time. And this is the same kind of concept, except it shows different tasks on the same CPU cores that are not truly executing in parallel, they're executing concurrently. And that is the world pre-Ruby 3.0. So in summary, we had thread.new that started native threads in Ruby, but we knew that it was bound to single CPU core. We also know that scheduling is performed by OS kernel with some feedback from the programmer via thread.pass. So we can call thread.pass if you wanted to release the control. Now, fiber.new starts a new lightweight fiber within a thread. And the only difference is that we actually have to schedule fibers ourselves, although that has changed lately with the addition of fiber schedulers. But the idea is that while threads sort of end up getting scheduled by OS, with fibers, you kind of have full control. So you can create a fiber that does I/O, yield it to another fiber that does something on CPU, and then yield it back when something comes back on I/O. So it's a little bit more fine-grained. In a nutshell, pre-Ruby 3, to take advantage of multi-core hardware, we had to either run something with multiple workers, multiple processes, run many single CPU Docker containers, and often run both of those with multiple threads in order to take advantage of any time spent in I/O. And it worked. We could saturate multiple cores, but multi-process architecture does require more memory and it's slower to start. And so real briefly, I want to touch on Moore's Law and why we ended up here. So you probably all heard of Moore's Law. It's about number of transistors growing sort of exponentially together with the speed of the CPU. And that sort of tapered off somewhere, if I'm not mistaken, around 2012s or 15s, and sort of continues to flatten. And so hardware manufacturers went white instead of kind of high-end CPU. We started having 2-core systems, 4-core systems, and now on AWS, you can easily provision a server with 512 CPU hyper-threaded cores. The question is, well, how do you run software that takes advantage of that? And that is what actually spurred all of this crazy creation of new languages like Go and Rust, those languages that have these concurrency paradigms. A single binary can saturate all of the cores in the system. Their concurrency paradigms, like channels, are pretty safe. They're not as susceptible to kind of typical problems with coding threads, with thread-related, thread safety-related issues, and similar problems. So Ruby was unfortunately behind on that front up until Ruby 3.0, when guilds, which were later renamed to Ractors, were created. So yeah, Ruby 3 was a bomb for me personally, and hopefully for everyone. So let's talk about Ractor and what the hell is it? So Ractors are Ruby's answer to actual true parallelism. Each Ractor has its own memory and runs potentially on a different CPU core. They're not bound to global interpreter lock. And the communication with the Ractors is possible, but it's only enabled through message passing, which is the only safe way to do it, and is similar how other languages do it. In a sense, sort of Ractors are like services that send and receive messages. The only thing is they live inside your Ruby binary, Ruby process. So it's like a thread, but can't share anything, although that's not technically true. And the best part about this is that a single Ruby 3 MRI process with Ractors can finally saturate every core on your system. Now I can mine my crypto. Finally, in Ruby. I lied when I said that they can't share anything. Ractors actually can share some objects. They're called shareable objects. And all frozen constants are shareable. Class and modules objects are also shareable. And what that means is that if your application is enormous and the class and module objects take up a ton of RAM, then running a single process that shares all of that among all the Ractors and then creating Ractors to do something will actually save you quite significant amount of RAM compared to running it in multiple processes. One of the things that I want to see is a version of Puma, for example, that instead of using multiple processes as workers, uses Ractors as workers, because that would obviously be much more efficient and also less memory. So that's pretty much the overview of all the constructs. I'm going to quickly show you some examples. Now, I'm not going to lie, these examples are from a blog post, which I will reference later. I just didn't think that there was a real need to create something other than factorial to indicate high CPU task. We all know what factorial is and how hard it is to calculate. And then this digest function there just sleeps for 1 second, so it's just sort of deliberately slow. And these examples here show basically a benchmark. At the top, sequential factorial. At the bottom, we are forking 4 times. And you can see that the difference between the sequential and process is, about 3x. So even though you would maybe expect 4x because we're studying it 4 times, but in this case, there's probably an overhead. But it's close to 4x. This example here does the same thing in threads. And this is where we see global interpreter lock in action. There's really no difference, even though we're running things in threads, because none of the threads are waiting on I/O. They're not doing anything that can help us distribute this on a single CPU core, and so there's no benefit whatsoever. This example shows you how to use fibers and how fibers sort of allow you to transfer and yield control from one another. At the bottom, you will see what is actually printed when you run this example. I did run it. It's correct. This is not a lie. What this shows is that if you're building a system that's concurrent and you're using threads, this type of code will likely go inside of your thread, where you will be sort of passing the control within that thread from fiber to fiber. But the way I see it is sort of a process is a superset consisting of threads. Each thread may have one or more fibers to provide fine and grained control. The other thing that I learned while preparing this talk is that fibers now have schedulers. And so you can actually use the async gem to set scheduler and just schedule work as a block like this. And in this case, they actually also work really well in parallel because obviously we are sleeping for 1 second, which is an IO operation. The final example here is with Ractors. And Ractors work very much like processes because you basically, there's nothing shared. We're studying Ractors. We're doing it 4 times. So we will saturate 4 CPU in this case. Now, the total numbers here are not exactly 4 to 1, but I'm sure if you run it longer, it'd probably be closer to that. And this right here is a little video that I put together. So I'm a big fan of HTOP. There's a bunch of tools nowadays that allow you to look at kind of systems performance. There's glances. There's a bunch of stuff written in Rust. This is HTOP. And the cool thing about HTOP is it shows you every single core on my Mac. There's 16 of them and how busy they are. On the left top, there's an example which uses Ractors. I'm creating as many Ractors as there are cores on that machine. And I'm grabbing that from etc. module and processors. And over there, I'm going to actually run it. So what you should see is once it's running, all of my CPU cores are going to be pretty damn busy. And this was never before possible with a single Ruby process. So I'm pretty excited about that. So here we Control-C that example. And it looks like I cut the video a little too short. But yeah, basically all the cores went down to 0 after that. The last few tidbits, there's a really helpful gem called async, which allows you to do things like this. So you can be creating reactors like that, and you can wrap your block in async method. It also comes with a sync method, which can be swapped out and effectively does it serially, but it works the same way. So that's a pretty useful gem to know. And then another useful gem is pretty oldie. It's called Parallel. If you ever need to start a bunch of stuff in multiple threads or in multiple processes, use Parallel gem because the syntax is pretty much the same. I don't know if they support Ractors yet, but I don't see why not. I'm sure they will soon. So in conclusion, when would you want to use which? That's a big question. So I think that processes are best used when you need real complete isolation between tasks. And obviously you want to utilize multiple CPU cores. Threads are great when you need lightweight concurrency within the process, especially for IO bound tasks when you're talking to database or caches. But be mindful of the GIL and thread safety. Fibers are great for highly cooperative multitasking or when you need to control your scheduling and manage your non-blocking IO operations efficiently. And then Ractors, use them when you need to run multiple CPU-bound tasks in parallel across many cores with a single process. And that ensures safe concurrency because there's no shared state and the results and inputs are passed as arguments and exits. That's pretty much it. If you want to work at Academia, please talk to this guy in mask. He's right there. This is a list of references. If anyone wants to read a little bit more on the subjects, take a screenshot of that. These are great posts to read about this a little further. And thank you very much. That's all I have. And, there any questions?
Okay, have you used Ractors, let's say at Academia, or maybe threads even. Like, have you used?
So what?
Have you used? This was a great great overview. I'm gonna say. I'm curious if you've, like, for example, at Academia, if you guys looked at something and you said, "Oh, it looks too slow," and we're gonna speed it up with async Ruby, or we're gonna speed it up with Ractors. Yeah.
Well,
Like a story.
I haven't yet done that specifically for work, but where I would say I would use Ractors is if you ever write a gem or anything like Puma, something that needs multiple processes or maybe already has multiple processes, it's actually quite a bit of pain. If you ever looked at Puma's code, quite a bit of it actually is all about managing process pool, catching signals, sending signals, and so on. And so I feel like Ractors could really simplify that model, where instead of having a pool of workers, you just have a pool of Ractors. And they will all be within a single process, which simplifies deployment, it simplifies monitoring, and all sorts of other things. So I don't really have a direct use case yet, but I do think that as Ractors become more widely known, as better gems come out to support it, we will start seeing things like Sidekick and things like Puma start using Ractors as an option.
Yeah, great. It feels like those kind of infrastructure level kind of performance heavy products, they can and SDKs for them, by the way, as well. Anyway, questions?
Good talk.
you.
I'm curious if you've run Falcon, like if you've run production workloads on that, or if you have any thoughts on Falcon.
No, what, Falcon, the Elixir thing, or?
No, Falcon, the Ruby web server it's built on top of async, the async gem.
No, I haven't run it. But yeah, there's a whole bunch of there is a Ruby web server that I saw that's based on async gem. Spent it on, I think, Event.io maybe. I haven't run it personally, but yeah, I mean, the great thing about doing Ruby today as opposed to 20 years ago is that there's so many options. You know, we have DryRB framework, we have Hanami, we have SQL gem for database connection. Like, you don't have to use Rails for everything anymore. And there's plenty of libraries that are way better at what they do specifically than kind of a maybe generic component out of Rails. That's not to say Rails is bad. Rails is great, but Ruby community has really grown and flourished, and I'm personally very excited for that.
All right. Okay.
Cool.
Konstantin, yeah, let's thank thanks.
Thank you very much. Thank you.
Great talk. Yep, and this concludes our event today. You all know the next one is October 10th on Chime. Please sign up on Luma. Yeah, submit to talks. By the way, I feel like the talk about Falcon is maybe due because we keep mentioning it. So if anybody's ready, please submit to talk about that. Yeah, just play with it on the weekend and, you know, just maybe run some benchmarks or something. That's a great way to start. And yeah, thank you all for coming. We still have time till 8:50, by the way. I'm not sure what. Okay, it's like 8:12 right now. We still have a little bit of time. There is still some soft drinks over there, I guess. And again, thank you all for coming. Let's chat, let's connect with each other. And I hope to see you next time. Thank you.